Students, welcome to my YouTube channel. In this video lecture, I am going to answer the next 10 questions remaining from Airborne Weather Radar chapter peak variance. So far I have done the first 50 questions. In this I will do the next 10 questions, 51 to question 60. So let's begin with question 51. The Airborne Weather Radar is using a 5-degree beam width. The cloud is detected at a range of 60 nautical miles. If the scanner is tilted up to 5 degrees, the cloud disappears. Using trigonometry to determine the height of the top of clouds in relation to airplane's cruising level, select the nearest answer from the following. So, beam width is given to us, range is given, tilt is given. You have to determine the height of the top of the cloud. Simple. So, height of the top of the cloud is equal to tilt minus beam width divided by 2 into range into 100. So tilt is 5 degrees. So 5 degree minus beam width is again 5 degree divided by 2. Range is 60 into 100. So 5 minus 2.5 into 6000. So 2.5 into 6000, that is equal to 15,000 feet. That means the cloud top is 15,000 feet above your aircraft height or aircraft flight level. So correct answer here will be 15,900 above aircraft is the closest answer. So I'll select option A. Next. Airborne weather radar is using a 3-degree beam width. A cloud is detected at a range of 40 nautical miles. If the scanner is tilted 3 degrees up, the cloud disappears. The top of the cloud in relation to airplane's cruising level is how much? So again, let's use the formula. Height of the cloud is equal to tilt minus beam width divided by 2 into range into 100. So tilt is 3 degrees. Beam width is again 3 degrees. Range is 40 into 100. So 3 minus 1.5 into 4000. So 1.5 into 4000, that is 6000. Okay, so correct answer is the top of the cloud is 6000 feet above your aircraft height. Next, 53. What frequency is typically chosen for airborne weather radar systems? So the frequencies that we use is 9.375 gigahertz or 9375 megahertz. And this falls in the frequency band of super high frequency. So 9.375 gigahertz, yes, option Charlie is the correct answer. Okay, direct question, factual question. 54. Airborne weather radar can be used on the ground provided aircraft is clear of personnel, buildings and vehicles. Conical beam is selected. Testing must be executed in accordance with specific health and safety regulations. Airborne weather radar must never be operated on the ground. So that is wrong. So the correct answer here is option alpha. You can use airborne weather radar on the ground provided you have taken all the necessary care and followed all the rules and regulations set by your company, manufacturer, government, right? Because airborne weather radar operates in the frequency band of super high frequency. Now, these frequencies are harmful for anyone working around aircraft. These frequencies can ignite fuel vapors. So, if fueling is going on, this can ignite those fuel vapors. Third, it can damage the airborne weather radar itself from all the strong returns from all the strong returns coming from nearby objects. So you have to take all the precautions and care before operating it on the ground. So correct option is option alpha. Next, 55. The cosecant squared beam is used for mapping in the airborne weather radar because it allows cloud detection to be effected while mapping, a greater range can be achieved, a large area of ground is illuminated by the beam, a wide beam is produced in azimuth to give a greater coverage. So correct answer is option Charlie. Now remember, whenever we use the mapping function of airborne weather radar, for the first 70 nautical miles, 60-70 nautical miles, we make use of fan-shaped beam, also known as cosec beam. For the next 70 miles, that is 70 to 150, we make use of pencil shape, pencil shape conical beam. Okay. So if this is your aircraft, let's say this is your aircraft. So for the first 70 nautical miles, it will transmit a wide wide radar beam. We call it fan shaped or cosec beam. So for the first 70 nautical miles, you have this kind of beam. For the next 70 nautical miles, that is up to 150 nautical miles, you have you have a very pencil shaped conical beam like this, a thin size pencil shaped conical beam. Now why do we limit the use of fan shaped beam to the first 70 nautical miles? Because this wide shaped beam covers a larger area than the conical beam. Second reason is that the concentration of energy will be distributed over a large area. So we don't want that. The concentration of energy will be distributed over a wide area. Third reason is that the reception is poor. And the fourth is that target resolution is also bad. So for these reasons, we do not use fan shaped beam beyond 70 nautical miles. Target resolution is also bad. Okay, so these are the four reasons. So the correct option here is a cosecant square beam or fan shaped beam used for mapping covers a larger area. Okay, it allows cloud detection to be effected. This is wrong. So we use pencil shape or conical beam for cloud detection or weather detection along with mapping, not the fan shaped beam. A greater range is achieved by pencil shaped conical beam. A wider beam is produced in azimuth to give a greater coverage. So Charlie is the correct option. 56. On a weather radar, the greatest turbulence is likely in an area where targets are. So again, I have explained this many times. You are going to expect heavy turbulence whenever you see different color zones, green, yellow, red, very close together. Okay. So shows a rapid gradient of change from magenta to yellow. Okay. So that is where you will expect greatest turbulence. That is change in colors, change in colors over a short, over a short distance, over a short distance. Weather radar is used by the pilot to assist in what? To assist in the detection of other aircraft through clouds. That is wrong. Detection and avoidance of potentially turbulent cloud cells. Yes. Detection and avoidance of turbulence. Detection and determination of a route through active cloud cell formations. The most appropriate option here is option Bravo. Now option Charlie also says detection and avoidance of turbulence. But this turbulence is also inclusive of clear air turbulence, wake turbulence, wind shear. Right? Airborne weather radar is unable to detect or spot or locate these three types of turbulence. That is wake turbulence, clear air turbulence and wind shear. So it will be more appropriate to say that airborne weather radar is used to detect and avoid weather which is potentially turbulent with respect to clouds, with respect to cloud cells, okay, which have large water droplets. So option Bravo is the most appropriate option. Select that. 58. The stabilization of the weather radar aerial is effective for up to plus minus 20 degrees. Remember this value. Pitch and roll. Only pitch and roll, not yaw. And the value is plus minus 20-degree combined pitch and roll. Next, 59. On an airborne weather radar, the sequence of colors indicating increasing water droplet size. Increasing. That means they are talking about ascending order. So first you always start from black, very light or no returns, followed by green, light returns, followed by yellow, medium returns, and the last is magenta red, which is heavy returns, severe returns. Okay. So option A will be wrong. Blue, we do not have blue here. Green, yellow, red sounds right. Black, amber, red, blue, amber, red. So bravo. Green followed by yellow and then red. Question 60. The colors used on a conventional airborne weather radar to indicate increasing intensity. So it is similar to the previous question. The wording has changed. Increasing intensity means again they are talking about ascending order of colors. So you always begin with green, then yellow, then red. Black, green, yellow, red. So green, amber, red is also wrong. Green, yellow, orange, amber, red. Actually, green, yellow, we do not have orange color. We do not have blue color. Bravo is right. Green, amber, red. Here, amber color means yellow color. So, green, amber, red. Option Bravo is the right option. So, this ends our lecture. I hope you have understood all the 10 questions I have answered in this video lecture. Very simple, basic theoretical questions and some numericals also. Do these questions thoroughly, do the chapter, theoretical chapter very nicely, mark the important points from that chapter and make notes of that. I have uploaded a lecture in which I have marked the important points from Airborne Weather Radar chapter from Oxford book. So do watch that video lecture. Now in the next video lecture, I will be solving or answering the last set of 10 questions from Airborne Weather Radar chapter key videos. That will be the last lecture of this chapter and this book. So don't miss that video lecture. Maintain consistency. I wish you all the best. Subscribe to this channel if you haven't yet and share this video with your friends who are preparing for the exam. Hit the like button if you have liked this video lecture. I'll see you in the next